Welcome back to Orlando Math Learning Academy. My name is Hui, and so basically I already finished chapter 1 of the textbook. I want to skip section 1.6 and jump to chapter 2. The first section of chapter 2 talking about system of linear equation and inequality, and how to solve system of linear equation and inequality. Before we get started, I want to do a quick recall about what we already learned in intermediate algebra. Okay, so put the topic today: system of linear equation and inequality. Okay. As you already learned in intermediate algebra, you learn how to solve a linear equation, something like 2/3 x minus 5 equal 2x minus 2 over 5, for example. So this is a linear equation. Why I say so? Because if I do a quick manipulation on the right side, okay, I kind of split up this fraction over here, and I see that the left side of this equation is a linear equation, and the right side of this equation is also another linear equation. Okay, and the left linear equation is in the slope-intercept form, so as the right side linear equation is. Okay, and when we solve for this linear equation, so basically we solve for the x value. Okay, so you solve for the x value, that is basically is the x component of the intersection point between these two lines. So if I just go ahead and rewrite the left side as a linear equation, slope-intercept form of linear equation, and I rewrite the right side as another slope-intercept form of linear equation. Okay, and when I solve for this, for the x value, which is the x component of intersection point between these two lines, and as you already learned that the first linear equation over here represent a line, the second equation over here represent another line, so these two lines might intersect each other. So when we solve for the x value, which is we solve for the x component of these two lines. Okay, so if I can rewrite the left side and the right side as up, and I add a bracket into that, so I have something called a system of linear equation. Okay, because I have more than one equation. If I have more than one equation, I call the system of linear equation. Okay, so the first part of the lecture today, we need to know what's meant by a system of linear equation. System of linear equation is a combination of two or more linear equations involving the same set of variables. For example, I have something like this. I have system 2x plus 3y equal 4 and 5x minus 2y equal minus 1. So when I say the same set of variable, I mean that the x over here is the same x, okay, and the y over here is also the same y. Okay, so in the example I have a system of two linear equations. Okay, I may have a system of three three variable. Okay, something like this. I have 4x minus y plus z equal 4x plus y minus 2z equals 6, or negative x minus 3y plus z equal 5. The difference between this system and this system is that in this system the linear equation represents the line. However, in this system, when we have three variables x, y, and z, each equation here represents a plane. Okay, so at the intersection point, the intersection between two lines, I have a point, and the intersection of between among three planes, I also have another point. Okay. However, if I go deeply into this, it might be a little bit different from the system of two variable or system of two linear equation, because this is linear line, and because this is the line and this is the plane. So I don't think that in this lecture I go too deep into a system of three variable. Okay, but I just want to let you know that if we have more than two linear equation, or more than two linear equation, then I have a system of linear equation. Okay, so as I say, the solution of system of two linear equation is the point. Okay, so then what is happening if we have the solution of two linear equation is a point, the intersection point. Okay, or when you have two lines intersect each other, then what is happening if we have two lines kind of parallel to each other and overlapping each other. Okay, so next I will categorize into three cases. Scenario for linear system. Okay, the first case I have two lines intersecting each other, and if I have two lines intersecting each other at one point, then that system I call the consistent and independent. Okay. The second case is that, and I have two lines parallel to each other, that I call this system inconsistent and independent. Okay. And the last scenario, when I have two lines overlapping each other. So when I have two lines overlapping each other, I see that I have many solutions, because I have a lot of intersecting points between two lines. Okay, then this system I call it inconsistent. I call it consistent and dependent. Okay. So in the second case, I see that we don't have any solution, because we mean that we cannot solve for x and y value. Okay, because you see that if we have two lines parallel each other, here we don't have the intersecting point, right? And in the last case we have a lot of intersecting point, and the first case I have only one intersecting point. Okay. Unlikely to solving basic linear equation, which we solve for only the x component of the intersection point. For the system of linear equation, we solve for both x and y component of intersection point between two lines. Okay, and there are three methods to solve system of linear equation. There are more, but in this list at this level, we only just three methods. The first method is using the graph. Okay, so let's jump to the second Roman method of solving system of linear equation. In the first method, we solve it by graphing. Okay, this method we will be graph two lines, and we find the intersection point of two lines. The coordinate of the intersection point of two lines will give you the solution of the system of equation. So for example, if I have the graph like this, okay, and two lines intersect each other at this point, okay, so the coordinate of this point, I call a point A over here, is the solution of the system of linear equation. The second method is we solve for the solution algebraically. The method is called substitution method. Okay, so in the substitution method, we use one of the equation for uh, x or y in terms of the variable, and we substitute that in second equation of the system. For example, in this example, I have the system like this: 3x minus y equal 4, and x plus 2y equals 6. So if I look at the first equation and the second equation, I realize that I can solve the first equation. I can solve for y in terms of x. Okay, what do I mean by in terms of? It means that when I solve for y, the left side will be y and the right side will be anything with x and the number. On the left side, only y. Okay, so this equation here, I can add in both sides by y and subtract by 4. Then I have y equal to 3x plus 4. Okay, so you see that on the left side I have only y. On the right side I have only with x and the constant term. Okay, after I solve y in terms of x, I substitute this back to the second equation. Okay, so this is the first equation, this is the second equation. I substitute them back. So the second equation becomes what? Becomes x plus 2. So I replace the y. With 3x minus 4. Okay, equals 6. No, 3x minus 4, I'm sorry. So now we have the basic linear equation, one variable. So we do the same way as we already learned when we solve a linear equation, basic linear equation in intermediate algebra. Okay, so I'm gonna just go ahead and distribute it. Then combine my term. Then I have x2. So after I solve the x component of the integration point, I might use either equation 1 or 2, or the equation right over here in order to get the y. Because the equation over here, we already got y in terms of the x, so this will be easy to use this equation. So I will plug 2. I replace the x here with 2. Okay, so y becomes 3 times 2 minus 4. So we have 2. So the intersection point has coordinate 2 and 2 as x and y component. In order to check your answer is correct, you can plug in x equal 2 and y equal 2 into both equations, and as long as you plug in the calculator amount and satisfy both equations, it means that your answer is correct. Okay. Let's do another example for substitution method. Okay, another example like this. X plus y equal 104. 2x plus 3y equal 344. Okay. So in the example number 1 and use example number 2 here, the system, the linear equation of the system is in standard form. Okay, so again, I'm going to pick the easy equation to start with, and by observation I see that the first equation is easier than the second one, so I can solve x in terms of y or y in terms of x. Okay, so let's do y in terms of x. We do the same way as we did over here. Y in terms of x, it means y on the left side, y on the left side, and everything move to the right side. So I have like this, and I have y. I replace the y of the second equation with this difference. So the second equation becomes this. Okay, now the equation we have is linear equation, basic linear equation. So we just go ahead and solve it as usual. Okay, and we combine our term and subtract both sides by 332, and I have x equal to 88. Okay, after I got x equal to 88, I plug them back into this equation. So y equal 144 minus 88, then I have y is 56. Then I got x and y component of the intersection point. The third method is also algebraic method, and I call it elimination method. Elimination method. Okay. In this method, we want to eliminate x or y depending on the system. Sometimes we eliminate the x, sometimes we eliminate the y. It depends on the system. If the system is easy for you to eliminate x, you go ahead and eliminate the x. Okay, so after you eliminate the x, your system becomes only one equation, one basic linear equation with one variable, and you can solve for that. Let's go to the example. we have the system like this. Negative 3x minus 7y equal 2x plus 4y equal 3. We're going to eliminate the x or y. In order to eliminate it, the coefficient in front of the x or y must be the same. Okay, so over here you see that the coefficient in front of the x is negative 3. The coefficient in front of x over here is 2. So it's not the same. So we cannot eliminate it yet. And over here, because the coefficient of y is negative 7, coefficient of y is 4. So it's not the same. So we cannot eliminate it. So how are we gonna make it the same? We can multiply the coefficient by a certain number. Okay. In order to make it the same. Okay. The same, it could be the same sign or different sign. Okay. So I will multiply the first equation by and multiply the second equation by 3. By doing that, I have the first equation become negative 6x minus 14y equals 16. The second equation becomes 6x plus 14 plus 12y equal 9. Now what? Now you see the coefficient of the x is negative 6. The coefficient of the x down here, the second equation, is positive 6. So it is kind of the same. Okay, I can consider it as the same even though the sign is different. Okay, if the same, then it's even better. Okay, but if the sign is different, it's okay. If the sign is different, we add. Okay, so the next step is we add in these two equations together. If the sign is the same, we subtract two equations together. So right now the sign is different, so I'm adding. So I'm adding the first equation to the second equation. If I add this, negative 6x plus 6x cancel out, right? So negative 14y plus 12y equal 16 plus 9. See? You see how I added? I add the first equation. I added the left side of the first equation to the left side of the second equation. Then I write equal. Then I add the right side of the first equation to the right side of the second equation. Then I have negative 14x plus 12y, and this gives you negative 2y, give you equal 25. Okay. Okay. Then from here I got y equal to negative 25. Oh. By doing elimination, we get rid of the x term. Okay. The equation after we do with the eliminate has only y term. Okay. If we want the x, the equation has y variable only. If we want to eliminate the y, the equation we have after eliminate has only x variable. Okay. So after I got the y, I plug it back to the original one. Can we plug it over here? Can, but the number is too big. I don't want to deal with that. So I plug into the easy one. So I plug into this. So I have negative 3, negative 25 over 2 minus 7y equal 8. So this will become what? 75 over 2 minus 7y equal 8. Negative 71 equal 8 minus 75 over 2. So it becomes 16 minus 75 over 2 equal 9. 59, negative 59 over 2 and y become 59 over 14. Oh, I plugged it into the wrong one, I think. So I should plug it over here, I'm sorry. So the equation becomes negative 7x minus 7 negative 25 over 2 equal 8. So negative 3x positive 175 over 2 equal 8. Negative 3x equal 8 minus 175 over 2 give you 16 minus 175 over 2 give you 159, negative 159 over 2, and therefore x becomes 159 over 6. So I have the x component of the intersection point, and I have y component of the intersection point. It means I have the solution of this system. Okay. The question is, can we eliminate the y instead of eliminate the x? Yes, we can. How we do that? We can multiply. You see that if I multiply the first equation and the second equation by 4 and 7, by 7 here and 4 here. Okay, so instead of multiply by 2 and 3, I multiply the first equation by 4. Give you what? Multiply equation by 4 give you negative 12x. 28y equal 8, right? And the second equation become what? 8x. 14x plus 28y equal 21, right? I multiply the first equation by 4 and the second equation by 7. And now you see, if I add in this equation and this equation, it will eliminate the y. Okay, it will eliminate the y. And if we can eliminate the y, the equation we have left is the equation that has x variable. Okay, this is the equation that has variable. And we do the same after we solve for x. We plug it back into the original equation to get the y. So instead of getting the y first, in this case, we get in the x first. Okay, then after getting the x, we get in the y over here. Okay, one more example about elimination method. Something interesting. Something interesting. How about like this? 10x minus 6y equal to negative 5x plus 3y equal 4. Sometimes you don't have to multiply both equations by a certain number. For example, in this equation, I just need to multiply the second equation by 2. If I multiply the second equation by 2, then the whole system becomes what? Become 10 plus minus 6y equal to the first equation of the system. I don't even touch it, so I leave it there. Multiply the second equation by 2, I give you negative 10x plus 6y equal 8. Now what? Now the next step is I adding the first equation and the second equation together. Okay, then what do we become? Become negative 10x plus minus gone, negative 6y plus 6y is gone. So everything on the left side becomes 0, and the right side becomes 10, right? And if you look at the statement, present right here, it totally doesn't make sense at all. How come 0 equal to 10? So if you do the elimination method, or even you do substitution method, and during the process, it turned out to be something doesn't make sense at all, then I can jump to the conclusion right away that the system has no solution. No solution. It means that graphically, uh, two lines, this line and this line will parallel to each other. It never intersects. Okay, so we don't have any solution. Okay, that is one of the special case, and you see that a lot. Though. How about like this? Well, like this. I have a system equation like this. And again, I want to use elimination method. I will multiply the second equation by 2. So the whole system becomes 10x minus 6y equal 12, negative 10x plus y equal negative 12. And after that, I add in the first equation and second equation together. I add this, give you 0, right? I add this right here. These two terms here, I added, give you 0. So the whole left side of the equation after I add is 0. How about the right side? I add 12 to negative 12. It also gives you 0. And by investigating this statement, I conclude that this statement is truthful all the time. This is fact. 0 equal to 0. Totally makes sense, right? It's like 2 equal 2, 3 equal 3. So during the process of elimination method or substitution method, and it turned out to be something make it sense. For example, in this case, 0 equals 0. Then I can jump into conclusion right away that system has infinitely many solutions. Graphically, two lines here will be overlapping each other. Okay. In the last part of the lecture today, I want to apply the 7 linear equation into a real-world application. I want to solve word problem by setting up a system of linear equation. When solving for x and y components or x and y variable of the system, we can solve for the answer of the word problem. Word problem. Example. I have the word problem as this. At Burger King restaurant, one regular hamburger and 2 cheese dogs have totally 1930 calories. Period. 2 regular hamburger and 1 cheese dog contain 2015 calories. The question is, find the amount of calorie of each main item. Okay. So when we when we do the word problem relating to serving system information, the first step is we want to know what we're looking for, and second step is we have to name the variable that representing for what we're looking for. Okay, so over here the question is to find the amount of calorie in each menu. Okay, and the menu we have here, the menu we have what? First menu we have regular hamburger and cheese dog. And the second menu we also have regular hamburger and cheese dog. So it looked like that if we name x, okay, x as the amount of calorie of regular hamburger and y which will be the amount of calorie of cheese dog. Okay, because that's what they want us to find, right? This amount of calorie of each menu. On the first menu we have one regular hamburger and 2 cheese dog. Right? I'm sorry, this is 2 cheese dog. The total is 1930. Okay, so one regular, we set up one regular cheeseburger be x plus 2 cheese dog, we put 2y because might represent the amount of calorie in cheese dog. Okay, the total is 1930 calories. The second equation is based on the second menu. The second menu we have 2 hamburger mean 2x, 1 dog, 1y equal 215 calories. Now we have a system of equation. Now we can solve for x and y at the same time. So as long as we solve for x and y, we solve for the amount of calorie of regular hamburger and cheese dog, right? And when we solve this, again, we consider what a method we want to solve. Since one method sometimes is harder than the other, so we always want to pick the wise one, the easy one. I mean, okay. Let's say, look like I love the substitution, so I go for substitution method. Because in the first equation here, I can solve x in terms of y. Okay. Then I use this equation I just got x from for plug it back into the second equation. Okay. Then now equation I have after plugging back is basically an equation with one variable is y, right? So I can solve it as usual. Okay. And by combine like term and subtract both sides by 3860, divide both sides by the coefficient -3, I have y equal what? I have y equal have y equal, let me see, y equal 650. Okay. It means that, what does it mean? It means the amount of calories in the cheese, in one cheese dog, is 600. Okay. Okay. So far we got a y only. We need to solve for the x. So I'm gonna plug in here. Become 1930 minus 2615. Then I got the x is 700. Okay. It means that one regular hamburger contains 700 calories. So the unit here calorie, the unit here calorie. Make sure you always put a unit for solving a word problem. We have about 32 problems in the as an exercise in the textbook. Okay, and most of them are very easy, and I think you can do that by yourself. The word problems require you to read first and require you to name the variable that represents for the thing you want to find. Okay. For the other straightforward problem, you just need to pick the wise method, substitution or elimination method. Okay. I don't know that if I should go through another one with fraction, a system of equation to fraction. I think I should. Okay, so let's pick another one. Let's solve another system of equation related to fraction. How about like this? This is number 16 on page 162. Okay, so look like the coefficient in front of the x, and here is fraction. The coefficient in front of x, here we have 1/8, and y is a half, is fraction. So how we do this? Okay, and because we have fraction most of the time, we should find LCD. So I find the LCD for the first equation. I have what? I have x minus 4y equal 1, and LCD here x minus 3y equal over 3. Then I multiply both sides by 8. The second equation, I multiply both sides by 3. And now what? I kind of simplify the system into something simpler. So I kind of bring all the fraction into a whole number here. Okay. Now the system become simpler, which is in the standard form of linear equation. The first equation is in standard form. The second equation is standard form. And also realize that the first equation and second equation had the same n. Okay, and it has the same sign because it's an x and x here. So instead of adding, I subtract the second equation by the first equation. So this is the first equation, second equation. So I subtract the second by the first. So 1 minus 2, 1 minus 2. So x minus x gone. Negative 4y minus 3y is negative y. 8 minus 6 is 2. So y equal to negative 2. So I got y equal to negative 2. I can substitute negative 2 back into either of them in order to get x. Then x equals 0. Okay. So by doing the elimination method, basically during the process we have to do substitution, right? So either way, either process, we have to substitute certain thing back to the original equation. Okay, in this case, I substitute negative 2 back. Okay. All right. Okay. Oh, here we have the solution. The intersection point has coordinate of 0 and negative 2. Okay. For number in the textbook, they also have fractions. So if you do the same way as I do show you over here, you should get the answer. First step is you have to find least common denominator. Then you just multiply both sides by the denominator to bring the system, the fractional system here into the standard form. That system. Okay. I think that's all for the second session of chapter 2. Next video, I will be talking about linear inequality, a system of linear inequality, how to solve a system of linear inequality graphically. Okay. I think that's all for the lecture today. If you like the video and if you want me to go through some certain problem of the textbook, don't hesitate commenting under the YouTube video and let me know which one you want me to go through. Okay, I'm happy to do that. Then I'll see you next time. Thank you. Bye bye.